Hello, good morning, and welcome back. Today we're going to continue talking about circles. Our first word of the day is chord. So right here I already have the definition. A chord is going to be not like in music when multiple notes are played, but it's a segment whose endpoints lie on a circle. Okay, so a segment whose endpoints lie on a circle is a chord. If we look down at our picture, like right here, AB is a chord because both A and B, the two endpoints of that, are on the circle. Our second word is an inscribed angle. This is an angles whose, oops, I made a typo there. Let's see if I can get that back. An angles whose vertex is on a circle, and not only is the vertex on a circle, and each chord or each side is a chord. Okay, so that is our inscribed angle. Pause it if you need to have more time to get those two down. All right, and our inscribed angles, as you can see, like AB is the chord, CB is the chord, vertex was B, that's on the circle. So the inscribed angle here is ABC. Okay, same thing for that picture. Now, our formula here that is important, our inscribed angle theorem, don't necessarily need the words, but maybe write this formula, draw the picture. It says the measure of an inscribed angle is half the measure of its intercepted arc. Okay, so the intercepted arc here for angle ABC, or we could call it angle CBA or angle B, all three of those mean the same thing. Half of what this arc would be. So AC, if we take half of that, we will get what this angle is. So now, find the measure. With that logic, also, I'm not quite sure why this happens, but the arc was supposed to be PR, arc PR. So we know that this angle is PSR is 80. We're trying to find what arc PR is. If we think about it, we said if we have the arc, we take half of it to get the angle. So we'll go the opposite. Instead of taking half of it, we will times by 2. 80 times 2 gives us 160 degrees for arc PR. That is a minor arc because it's less than 180. We talked about that yesterday. Example 2, you'll do the same thing. We're trying to find now arc RV2 or RVT. Now, since there's three letters, we know it's 180 or greater. It could be a semicircle if it's exactly 180. If it's more than 180, it'll be a major arc. So we take 91 times 2. We get 182 degrees. So it will be a major arc. Now that's what we do if we are given the angle, we need to find the arc. Sometimes it's the other way around. Like here, we are given the arc, we need to find what is this angle. So I'm looking for an inscribed angle. I just take whatever the arc is, divided by 2. So I'll get 70 degrees for this one. And on our next one, I have the arc, and I need to divide by 2 again. So 88 divided by 2 leaves us with 44 degrees as that angle. All right, number 5. In circle C, it says the measure of angle BED is 60 degrees. So BED right here, that's going to be 60 degrees. And my job is to find the pink one I'm about to highlight. It says find right here what BCD is. So BCD. So BED we already know is 60 degrees. We're trying to find what pink one is. So the blue one, first decide, is it an inscribed angle or is it a central angle? And in your case here, it is going to be a inscribed angle because E, the vertex, is on the side. So if BED is 60, we can double that. And we know that this arc from B around to D is 120 degrees. Now BCD, the pink one, that is a central angle. Central angles are congruent to their intersected arc, so BD is 120. That means that I know that BCD will also be 120. And I am done. Okay, the next one, once again, here it says SVU. So SVU, that's our inscribed angle. It's 23 degrees. And we know that it is, if we double that, we'll get SU is 46 degrees. Okay, and then STU. Okay? We want to know what STU is. So STU, the central angle, and if that is a central angle, then how about if we think about it, we know the central angle and the arc are the same, so that would also be 46 degrees. Okay, the final thing, I'm not worried about those questions, but I want to examine this diagram. And we want to try to fill in all the missing blanks. So we're going to solve what is this arc from Q to P, what's the arc from N to O, what are each of the angles within these triangles inside this quadrilateral here. So first thing, QP. So QP right here. And the way we can find that, we know the whole circle around the edge is 360. Right now I know from Q to N, arc QN is 120. I know arc OP is 70. So if I think about it, I will need to find what is QP. Okay, so if the whole thing's 360, QN is 120. We can take from P over to N. This is the diameter through the middle, so that is half of it. That is a semicircle. If that's a semicircle, then that allows me to know that from P to N would be 180. PQN is 180. We already have 120, so 180 minus 120 leaves us with 60 degrees right here. On the other side of the circle, it's the same thing. N to O to P is 180. 180 minus 70 leaves us with 110 degrees. Okay, at this point now, let's start finding these angles. So first angle we're going to find is right here, NPO. So I want to know, what is this angle? First, decide, is this a central angle or an inscribed angle? And since the vertex right here, P, is on the circle, it is inscribed. The opposite side of the circle there, this arc is 110, so we take that divided by 2, we get 55 degrees for what that angle is. Okay, next, let's solve for over here. So ONP, same thing. We'll take 70 divided by 2. We'll be left with 35 degrees. Okay, and our final one, if we highlight here from P to O, so PON, remember we trace this side, so this arc is 60 plus 120, that's 180. Divided by 2 would leave us with 90 degrees. The other option, you could have added 55 and 35, got 90, taken that from 180 because the whole triangle always adds up to 180. Either way, you'll get your answer. Now, let's go to the other side of the circle, the other triangle. And if we connect N to P to Q, that angle, we take 120 divided by 2, we get 60. All right. Our next one, let's go ahead and QNP. That's 60 divided by 2 will give us 30. And our final one, PQN. Once again, semicircle, half of it is 180. Divided by 2 is 90. All right. Today on the assignment, there's a couple different problems. Let's see. Let me show you a few of the delta math. Like some of them, you are just going to look. Here's a central angle. FGH, if this is a central angle, we know that the arc here, FH, is just exactly the same. It's 132. Let me show a specific type. Some of them, like here, it's an inscribed angle. So if it tells us DGF is 49, we're trying to find DF. We multiply by 2 to get that. Okay, so a couple different problems like that. If you need help, please let me know. Hope you guys have a great day.